We're going to take a look at some fractions again today. So I'm going to start off by reminding you what a fraction is. So fraction is just the name that we give to a part of a whole shape. Sometimes it's a whole group of things, but for this, we're going to talk about whole shapes. My whole shape here is a rectangle. Okay, and if I were to cut that rectangle into two equal parts, then I can show that by having a 2 at the bottom of each of my fractions. That shows that there are two equal parts, and then I name each part by saying this is one of two parts, and this is one of two parts that make up the whole rectangle. In this bottom one, these are called thirds because I had 1, 2, 3 equal parts making up this whole rectangle. Each one of these is one of the three parts. There's 1/3, this is called 1/3, and this is called 1/3. Yesterday, I showed you a fraction that looked like this. It said 2/3, and we shaded two of these thirds. And it changed the top number to be a 2 because what this is naming is two of the thirds as a part altogether. So if this is 1/2 and this is 1/2, this is 1/3, 1/3, 1/3. When we do rectangles like this and we break it into 4 equal parts, we're going to call those fourths. Another name for those fourths are quarters. So here's 1/4, one of the fourths. This is one of the fourths, and this is one of the fourths. So if someone asked me to shade 1/4 of this, I could shade this part, I could shade this part, or I could shade this part, or I could shade this part. So what you're going to see in some of your work today, something that looks more like this, that doesn't name each part on it. And it might ask you to shade half of this. And I know that the fraction for half looks like that. And I know that the number on the bottom tells me how many equal parts. But this has 4 parts. So I'm going to have to think about this and think, even though this is showing 4 parts, is there a way I could look at this and see the 2 parts of it that would be equal? So could I have this part and this part? They would not be equal, right? What if I folded it like this? I've got 2 of these rectangles on this side. Got 2 of these rectangles on this side. So now, is this part equal to this part? It is. So I actually, on the back, showed it this way. So even though this was all folded and had lines on it that made 4 parts, I can still see that half of this rectangle is this. The other half of this rectangle is this. So if I see that, and it says to me to shade 1/2, I'm going to do 2 of these because that would actually be half of the whole of the entire or the whole shape. So here I've shaded half, even though it had 1, 2, 3, 4 parts. If it asked me to shade 1/3, I don't have thirds here. I would have to fold this in a whole new way to make this make 3 equal parts. I wouldn't just shade 1 of the fourths. I would have to shade 1/3. It's only a third if it has 3 equal parts. So the other thing I have here is this. And if I were to be asked to shade half of this, well, this is a lot like what we just saw, right? I could shade half of it and know that by folding it, I could turn these 4/4 into 2 equal parts instead. And then each one would be 1 of the 2 parts, 1 of the 2 parts. I'm going to show you how I could make it match up with this by cutting it. So taking my scissors, and I'm cutting this rectangle. I'm going to put, now I've got 2 smaller rectangles, and put them on top of each other. And now I'm going to lay them on the table so they're nice and flat. I'm going to tilt the camera down so that you can see where I've actually got a square. Okay, so now I have a square that is divided like this: 1/4, 1/4, 1/4, 1/4. This is half of that square. This is half of that square. The other way we could do it is that this could be folded like that, and that would be half of the square. Or that would be half of the square. Okay, so I want you to experiment today a little bit more with making some rectangles and squares, folding them into halves and quarters. Quarters are the same exact thing as saying 1/4, okay? 1 out of 4 pieces. The other thing I experimented with a little bit were some circles. So I had this, you probably have a cup at home, and I put the cup down on a piece of paper and I traced it. Then I cut it out and I actually folded it. So when I fold it like this, I made a half and another half. That's what happens when I fold it into 2 equal pieces. And I give each piece a name by saying it is 1 out of 2 equal pieces. There are 2 pieces that are equal. This is 1 of the pieces. This is 1 of the 2 pieces. On the other side, I double folded it. So I did it into half and then I folded it again. So I wound up with 4 equal parts. So because there are 4 equal parts, the 4 goes on the bottom. The number on the bottom is called the denominator. So there are 1, 2, 3, 4 equal parts. This right here is just 1 of the 4 equal parts. This is 1 of the 4 equal parts. Okay. This is 1 of the 4 equal parts. And this is 1 of the 4 equal parts. So I will always have the same number of parts as I have for the denominator. So there were 1, 2, 3, 4 parts. So that means to make the whole shape, I'm going to have 1, 2, 3, 4 quarters. And these, if I cut these or folded them, they all overlap right on each other to show me that they're the same size. I'm going to have you, before you go off and do the page that you're doing in your Home Connections book, which is page 85, I'm going to have you just look at these 4 circles. And I'm going to ask you which one of these circles is divided or broken up into thirds. Which one is broken up so that I could write this in each part? Could I do it here? It has 3 parts. 1, 2, 3. Could I do it here? This has 3 parts. 1, 2, 3. This does not have 3 parts. This just has 1 part. This is just one whole. This has 3 parts. 1, 2, 3. So in which one of these shapes do you think I could cut out each part, lay them on top of each other, and they'd be the same size? Well, certainly not this, because you can see that this part is much bigger than this part. So even though it has 3 parts, I can't put fractions on there. Fractions only work if each part is an equal size. Same here. That's much smaller than this. We can see it just by looking. This doesn't even have any parts, so that's not fractions. So it's this one. If I were to cut that out and cut that out and cut that out and lay them on top of each other, these would be mostly equal parts. I wasn't exact, but this would be the one where I could write 1/3 on each part. There are 3 parts altogether, and each part is one of the parts. 1, 2, 3. Okay? Not this one, not this one, and not that one. They don't work. All right. Enjoy. Please, you can cut out some circles, you can cut out some squares, you can cut out some rectangles. Try folding them and seeing how many different ways you could turn it into equal parts. Okay, enjoy.